I wanted to provide an update to the biclustering approach that I presented earlier that was using Excel. So we've moved from Excel into Python, and I wanted to demonstrate the difference between spectral co-clustering, which is a popular algorithm, and our approach, which I call Quadratic Biclustering system. So spectral co-clustering can be downloaded off the internet, and you can run this code, and it can run really fast and really well, especially if the number of clusters is relatively small. So if I run this with 5 clusters and a relatively small matrix of 250 rows by 50 columns, it runs very fast, and it finds a good match to the original data. So it's a consensus score of 1, where the consensus score is based on the metric of, is this ij element a member of a bicluster, yes or no? And so in this case, all these and all these match. Now if I change this from 5 to 10 and run it, you can see that it doesn't work as well. That as you increase these number of clusters, they get smaller, and the spectral co-clustering doesn't work as well. When we run our system, it's a little bit slower because I'm iteratively going through all these modifications to the matrix that I'm making, but it provides much better output, especially for these larger ones. For the smaller ones, they have similar performance. But as the number of biclusters gets larger, the performance is much better with this approach. So here's the original, which is the same as the spectral co-clustering original. Then we scramble all the data, and then we look for biclusters in the scrambled data, and it matches very well. This one matches with this one matches with this one, and it's a very good match to the original data. There's a little bit of noise here, and if we increase the amount of noise, you'll see those artifacts appear in the results.